Hello everyone, this is a video for module KV7006 Machine Learning. I'm Nanling Jun. This is a video for clustering. Clustering is one of very important machine learning methods. It's a typical unsupervised learning method. Unlike classification, where we have class label, which is a variable which helps us classify objects. But in clustering, we don't have any class label. So we need to find ways without class label to group things together. For example, if we look at the diagram on our left, just by visualization, we could see two groups. However, we probably need to use proper machine learning ways to group them together. So this is very important for pattern recognition, for data segregation, to divide the data. So mathematically, clustering could shape off in this way. So given a vector x, which have n features in our dataset, they are all real value. We got n observations in a multi-dimensional space, in the space. So some people call variables or features or attribute the same thing, have an index, right? So observation are indexed by I, which is the variable which has everything in the vector. So given the diagram on our right, we got two features or variable here. One is income, one is debt. Okay, so we only have x1, x2 in this case. One is income, one is debts. So we got data samples in this two-dimensional space. So we want to divide them into a number of groups, each group called cluster. So unlike classification, we got no penalty, no way to calculate misclassification. Therefore, we need to use clustering to group them together. So just by looking at the diagram, clearly we can see samples in the yellow circle, they are grouped together naturally because they are very distant, have a large distance with samples in cluster 2 and the large distance of classes 3. So some people say clustering is based on the distant model. That is true. So based on how distant one cluster from another one. If one sample, let's say we're already clustering 3 cluster here. For example, if I got a new samples come in here, in my mouse here, we will automatically know it belongs to cluster 1 rather than cluster 2 and 3. The reason is they are more similar to cluster 1, given the two value, income and the debts. So distance becomes very important measure in the clustering. So you will know naturally. For example, if I got another sample here, we are not sure because they are quite equivalent to each cluster. Okay, we will explain later on. So the goal of the clustering is every samples in a cluster must be closest to each other. In another way, they must be similar in terms of features. For example, in this example, so the x1 value income and x2 value that must be very close to each other within one cluster. So observation in different clusters are not similar. So we want, on the other hand, every sample here in cluster 2 are very far from every sample in cluster 1 and very far, for example, in cluster 3. The further, the better. So that is a tool underneath concept how we are making clustering of data samples. So this similarity measure, which measure this similarity. So we assume cluster 1 and cluster 2 are dissimilar to each other. So they should have long distance, long distance, long distance. So we use this similarity matrix. So that actually is the dissimilarity or distance, you know. And then simply in our previous example, we got two-dimensional, right? So we can calculate the difference between the x1, xi in one dimension, or we compare them different dimension. So we can either use the distance, absolute distance, or we use the power of the value of distance. So they are both absolute value. There are no negative value. And then this is on one dimension, and we calculate the multiple dimension. So we times the weight. If we want, we focus more on XL. For example, we pay more attention on XL rather than YXL. We calculate the weight on each dimension. Okay, so then we calculate every samples in that class. K is important assignment observation to cluster K. So we assume we have number of class which equivalent to K. So within one cluster, we use this formula I explained. Between the cluster, we will use this formula. So let's go back to the diagram. So within a cluster, we want they are better, more similar, each sample to another one. The more similar, the better. Between each cluster, we want the more distance, the better. So we use this one to calculate the distance. So traditionally, there are several clustering methods. K-means, this is the one we are going to focus on this video. We also had hierarchy clustering. We won't have time to cover in this video. And we can also have parametric or non-parametric clustering. This video only covers K-means clustering. Okay, so this is an example with very, very simple sample for us to understand. So T-shirt have a different size, okay? So each sample is a person who has measured their weight and height. Okay, so and then each dot represents a person. So they need to buy a T-shirt, which they need to find the right size for them. Okay. Common sense is if we have young children, little weight, we buy baby T-shirt. If it's adult, very tall and heavy, they will buy large size. So this is common sense. Okay, so then we group them to different groups. Small, medium, and large in this case. So what this can do for us? So given a person, they are not in the data set, we will know approximately they will wear they're better for what kind of T-shirt. For example, if we look at this sample in the corner, although it's quite tall, but its weight is quite small, so compared to this one. So these two and these two. So this one is quite tall, but slim. This one probably is well built, is like a teenagers, for example, but it's it's smaller, it's shorter than these adults, slim adults, but the weight are the same. So in this case, although their weight are the same, because this adult, slim adult, is taller, so he's better to wear a medium-sized T-shirt. These teenagers, although the weight is the same as the slim adults, but because he's shorter than another person, he's better still wear smaller size. So you can see there's balance here. The principle of K-means clustering is to divide observation in number of space. They are not overlap. So in reality, in some research, clustering can overlap, but this is out scope of this video. So basically, we have one data set, two-dimensional. We can visually say, if we have two equivalent 2 and it's divide them 2, I can just draw a curved line here, so divide them 2. But if we want to divide them 3, I'm not sure this is the best way. Anyway, so this second group divided by 2, subgroup. And then 4, we divide them by 2 groups. 5, we divide this big one to 1, 2, 3, 4, 5. You can see, just by looking at that, K is very important, the value of K. So something, naturally they are not very good way to divide the data set, because you could see they're very, the group are not, the density of each smaller class are not density enough, because you can see this sample even further within the blue cluster, even further than another one in dark green one, the distance to the cluster. So this actually is not ideal way to do clustering, as output. Because the density of this one, this is a good one, the density is good, but here they have some samples quite further away from other samples here. So you could see density play an important role. Just by looking at that, you can naturally divide them to 2 groups. So how to determine K is also a research topic. There are many ways to do that. For example, use a density function. Compare the output of a range of K value and determine the distance, average distance of each cluster, and that is an empirical way. So there are many ways in research to determine number of K, but that is a topic we are not going to include in our current video. Procedure. We want to minimize within cluster distance. So we want that smaller as possible, which means we want every sample close to each other. Within that class, they're very close to each other. So we want to minimize them. So actually this is the one we have seen. So number of observation and on different dimension. So we measure the distance on each dimension. On the previous diagram, we only have two, x1, x2 dimension. So the procedure code is to pick a number of K. I know it's difficult to choose the right number of K, which is a research area itself. Imagine we have already know what is the best K for us. So we select the K centers. So each center represents a center of a cluster. So we got the K centers. So assign each observation to the closest center. Okay, we put there. Recalculate the center. The center could move because center is the calculation of the middle of the cluster. So if we put a new sample in, the center of cluster will move because it depends on the new sample. So in our packages, for example, we got a dataset with a number of K pre-chosen, and then start from, let's say, random C start from 20 points. Okay, so this is our dataset, and then, so for example, I choose the middle one first, and 1, 2, 3, 4. Okay, I choose one cluster first, and then we choose 4. Okay, 1, 2, 3, 4 cluster. Okay, so all purple one belong to this one, all blue one belong to this one, and all dark green belong to this one. This is the center. Okay, and then we add new samples in. You can see that it will be better these few samples belong to this one rather than in the center one. Here almost remain the same. Okay. Similarly, purple is still here, so now I took out a few samples and only keep my densest cluster all purple here. So I put everything here almost dark blue here. And also previously I got more samples here. Now I remove some and remove here. Here's mainly same. Similarly, you can see I remove dark blue one, only keep remain here. So center of the light blue is this one. Center of dark green is this one. Center of blue purple one is this one. Center of dark blue one is here. So 4 classes has formed. Okay, I'm having a question for you. If I have only 2 clusters, K equal to 2, what would the best option for you? That is homework. Simple code. This is a simple procedure code. We could learn, just 1 second. We could use, okay. Basically, I got a random normalization and randomly search the datasets, and then we use k-means. A lot of packages has k-means function. It's very, very common. And you got a starting point, 20 samples as a point, and then you naturally find out what is the best group for you. Here we got k equivalent to 3. Okay, data point is the data sample. Okay, we start with 20. Okay, and then here is naturally they are very nicely divided by nature. So in the end, we try to move clusters close to each other, and what happened with K means cluster. They will also have ways to measure the performance or output of K means clustering, also depend on the distance. So compare this way of clustering and this way of clustering. Certainly we can see that this one performs better because within cluster they are closest to each other. Between cluster they are distant to each other. And here it's quite mixed. So some samples are not nicely density enough to close together. So determine K, I'll briefly cover that. So here is one way. So imagine my K equivalent different values. So I'm going to do different tests within groups of the squares. Okay. So given this data set, I try. So K equivalent to 0 is meaningless, right? Every sample are within K equivalent to 1. So from 2, so we can see that it's decreasing. Choose the K that's lost a significant reduction within group sum square. So which means we choose the smallest sample number of K which achieve the smallest distance within classes and make the largest between classes. Some tips for understanding K means clustering. Solution depends on start of center. It probably sometimes to find the local optimum but not the global optimum. So that's why we need to start with different K means center to start with. Cluster assignment are strict. So if you with one class, you cannot be in another class. They are exclusive. So occasionally we have difficult to understand why this is the center. Because center the average value of the distance within that cluster. So in terms of images, clustering may not be very helpful because if white and black, two variables, so we probably cannot use that one because this is white, this is 1, 2 class. So for image analysis, there probably is different challenges. K means clustering may not be the best way to use it. So in summary, we have learned K means clustering, the clustering concept in this video. So basically what we want to achieve, one is to find the right K. Okay. We want to find the right number of K. And then we want every sample within a cluster is closest to each other. The density is high. We also want to find the distance between each cluster or further apart. So we group them together. Just remind you, in clustering, there are no class label. So end of the day, we just know we group them to 4 groups, but we probably cannot describe them in a certain way, like what kind of classes. So this is unsupervised learning. It's ideal for dataset without class label. So that is clustering. Thank you very much. I'll meet you in another video.